Hello everyone, thanks for taking the time to view this presentation about operations management for the construction industry. My name is Joseph Hall and I'm a student at Southwestern College. Today I'm going to talk about the productivity and strategy, forecasting, product, service, quality management, human resources, supply chain management, and how firms within the construction industry attempt to achieve the competitive advantage. Here's a look at those topics. Okay, let's go on to productivity. For the small independent operator, the productivity is based on the metrics of an individual project. For example, when a firm takes on a project that consists of installing a new septic system, the input for this project would be the septic system hardware, such as the tank, the distribution box, the pipes for the leach line, the heavy equipment, the operating costs, fuel for the heavy equipment, and the operator. And the output happens once the job is completed. After the project is completed, analysis will determine the productivity in terms of projected profit versus actual profit realized. And the productivity can be impacted by cost overruns in regard to added material or extra man hours. And if any of those occur, then management should find ways to eliminate those overruns in the future in order to become more productive. So here's a look at the strategy. So I found that small firms tend to rely on three strategies. They focus on differentiation by being proficient on many things and not specializing in only one area. Secondly, they strive to deliver services at a cheaper rate than the competition by taking advantage of suppliers of the raw materials and hardware that they use. They also operate on slim margins for fixed costs like fuel and labor. So, for example, if a project requires a certain amount of concrete and the firm has a long-standing relationship with the concrete supplier, it can possibly get those at a discounted rate, and which then they can pass along to the customers. So let's see what else. And then the last thing they do is respond to the customer by tailoring the services to meet specific requirements. And this lets them offer multiple choices for customers, which contributes to the competitive advantage. So forecasting for the construction sector has several approaches. They use three specifically, though. It's the causal forecasting models, time series forecasting, and qualitative forecasting. There's a company in the UK that claims that this three-pronged approach helps them develop a robust construction forecast and gives a more solid foundation for planning than the usual gut feel estimates. Both the causal and time series forecasting models fall into the quantitative category of forecasting. A construction firm using the time series model would reference historical data looking for trends that are similar to forecasted economic conditions, and then they can apply that logic and to assume or to determine what outcomes happened in the past and apply those to the future performance. The same line of thinking holds for causal or associative models. Construction firms look at future indicators to forecast the requirements. And a lot of people or a lot of firms think that combining the forecast from different forecasting methods is a procedure commonly used to improve forecasting accuracy. Firms also need to consider technological trends for long-range forecast. Things like autonomous vehicles are being developed that can replace the need for heavy equipment operators. So this has huge impacts on the cost of labor, probably will cause labor costs to go down in the future. So let's look at the product and the service development. The commercial construction industry is very complex and includes many firms that provide a wide range of services. The independent contractor will design its services based on the needs of the customer. If the consumer demands a fixed price and a schedule, like a fixed timeline for the project completion, then the contractor must design his proposal based on the plans and specification. The customer then decides if the proposed outcome is an acceptable level of quality. If the quality is not acceptable, then the customer must consider other proposals or change the terms related to the price and the schedule. So this is kind of a free market principle in that it creates competition among the contractors to meet the customer demands, and ultimately the customer decides which one to go with based on the level of quality for the price he's willing to accept. So let's go into quality management. There's no single quality management system that stands out for the construction industry. However, every project has the same fundamental requirements for quality determination, or for determining their quality. Each project has a plan with a list of tasks that must be completed by a set standard. General specifications of work quality are available in numerous fields and are issued in publications of organizations such as the American Society for Testing and Materials, that's ASTM, and the American National Standards Institute, ANSI, or the Construction Specifications Institute. The project managers must ensure tasks are completed in accordance to applicable guidelines. For example, soil compaction, strength of concrete, welding, are traditionally checked or tested by a third party. These tests are conducted during the execution of the work, and the quality of the product is determined and reported shortly after the tests or inspections are made. So quality management certainly has a role to play in the construction service development process. It's the fundamental driver of the design of a project because it is determined by the customer and by industry standards. The customer determines what the acceptable level of quality based on the key factors of cost and time. Let's go on to human resources. In general, heavy equipment operators should be well-rounded and proficient on various pieces of equipment, everything from backhoes and excavators to bulldozers and dump trucks. The industry needs a workforce consisting of individuals who can operate several types of equipment because equipment needs change from project to project, and operators may work on projects across every construction discipline, including commercial, residential, heavy civilian, and power industry or industrial. Therefore, it's crucial that, or not crucial, but specialization is not ideal for heavy equipment operators. They need to be well-rounded. So, but on the other hand, job expansion is the goal, since construction projects include tasks for multiple types of equipment. Now I'll give you an example. So say you're on a site clearing project, and it includes loaders, or like front-end loaders, excavators, and dump trucks, and it takes a crew of operators working together to get this done. If the crew members are trained on just one piece of equipment, then there will be delays when one of those members are absent, for a family emergency or illness or whatever the case is. So if you only have one driver for a dump truck and that driver's out, then you have no one to cover down. So that's going to cause delays in the process. Whereas if everyone is trained and proficient on all the machinery and have a valid commercial driver's license, then the absenteeism becomes less impactful, because you can just cover down, or someone can cover down for that person that's away. So when your operators are well-rounded, this provides a competitive advantage over a crew that only has that don't have the CDLs or isn't qualified on every piece of equipment. They're going to be delayed, whereas your crew will not be delayed. So let's talk about the psychological components. You want, part of the job design is having people feel like they're feel empowered through, or not empowered, but like they're contributing to the community, not just in contributing to their employer and helping their employer out, but they're helping the community at large out. So, that's easy for if you're on a road project, or you're constructing a bridge or some kind of dam, or a hydroelectric power plant. You're doing the site work for that, site preparation for that. Then it's easy to say, hey, that your crew is going to feel, or that person doing that job is going to feel like they are part of something bigger than themselves. So that's the psychological component. And then let's talk about self-directed teams. So each crew is a self-directed team acting under the supervision of a site foreman. The foreman gives the crew's leader the directions and the timeline for what needs to happen, and then the crew works in a semi-autonomous mode and gets the job done the way that they are used to doing it, or the best way that they can do it, that works best for them. And then the last one, the motivation and incentives. The construction industry uses incentive programs to motivate and reward specific results and retain key talent. The incentive is usually based on a predetermined timeline for a project. For example, if the site preparation is completed ahead of schedule, then the crew will split a percentage of the firm's savings, either monetarily or paid time off, based on a set standard. And then let's talk about the ergonomics of the job design. Heavy equipment operators endure a variety of health hazards, such as whole body vibrations, dust, diesel exhaust, temperature extremes, noise, awkward posture due to placement of controls, and the stress associated with timelines and shift work. But in the recent years, manufacturers have made tremendous progress with cab design and have eliminated or diminished the harmful effects connected to operating or associated to operating heavy machinery. Steering wheels have been replaced with joysticks, shock absorbers strategically placed with the operator in mind to allow for the smoothest ride. It decreases the vibrations. And then you have the cabs that are insulated, that decreases the noise levels, and climate control for heat and cold. But although much progress has been achieved, it does not replace the need for human resource professionals to establish appropriate mitigation controls to address other environmental risks. The outdoor environment plays a huge factor in the life of a construction worker, and the nature of the industry requires that workers be exposed to the elements for much of the workday. So they have to deal with nearly every weather condition, and they get dirty, greasy, muddy. But it's incumbent upon the operators and their supervisors to adhere to and enforce the safety standards. HR professionals and operations managers need to consider job design, ergonomic, and environmental factors and how each relates to the heavy equipment operators in the construction industry. The crews, they work in self-directed teams because this approach allows for a certain level of autonomy which can be motivated and incentivized by beating prescribed deadlines. So okay, back to onto supply chain management. Here's some challenges and opportunities. The challenges with the supply chain are related to coordination of all material and equipment coming into the site. Site preparation is comprised of a series of sequential activities, and much attention should be given to planning each step or phase. For example, when the site preparation includes large quantities of concrete, the project manager must accurately predict when the concrete needs to arrive. This requirement necessitates or requires coordination with the concrete supplier. If there are problems with the concrete delivery, or their capacity is limited due to conflicting requests from other customers, then this could cause delays, and that will result in a domino effect for the overall project of the building project. So the opportunities come in and can be and offer advantages for construction firms. The supply chain should be integrated to allow for the coordination of equipment and supplies entering the construction site. According to the authors of Supply Chain Integration Within Construction, it says, if aggregated demand is presented in a consolidated way to the market, a single supplier or fewer suppliers may respond in contract, with the potential to better manage information, lower prices, to reduce production costs, better management of the supply chain. Basically, the contractor's project manager and the supplier should work closely together to coordinate the arrival of supplies to the job site and prevent a bottleneck of resources. If executed effectively, this process will result in faster site preparation completion, which can translate into higher customer satisfaction. Supply chain sourcing strategies. Okay, the type of sourcing strategy used by a construction company most likely depends on the volume of the project in its portfolio. If a small operation does not have a demand for large quantities of supplies, then a strategy would probably be to look at as many suppliers as possible to find the best deals for materials like the wood, gravel, septic system components. On the other hand, if the company has a need for large quantities, it can use the economy of scale to negotiate a better price. So we talk about vertical integration, and that's really for firms that are huge that can manage the supply chain from top to bottom. But the small firms, they're probably not going to be able to do that. They're not going to have their own rock quarry, or they're not going to have their own concrete factory. So as far as vertical integration, that's probably not going to happen with a small firm. So covers the supply chain. On to the conclusion. Okay, so small construction firms use differentiation, reduce cost, and responsiveness as part of the productivity and the strategy to achieve the competitive advantage. They use causal, time series, and qualitative models to forecast future requirements and develop the most productive course of action. Quality is the fundamental driver of a project because it is determined by the customer. The customer determines what is an acceptable level of quality based on the key factors of cost and time. HR professionals and operations managers need to consider job design, ergonomics, and environmental factors and how each relates to the heavy equipment operators and construction industry. Construction crews tend to work as self-directed teams because this approach allows for a certain level of autonomy and can be motivated and incentivized by meeting prescribed deadlines. Heavy equipment operators that are proficient on many types of equipment will contribute to efforts to gain the competitive advantage. And finally, proper supply chain management will allow site preparation to be completed either ahead of schedule or at least on time, which can improve customer satisfaction and provide the competitive advantage. This concludes my brief. The next few tabs have all the references. Thanks for watching, and I hope you have a nice day. All right, thank you.